3D bioprinting of human organs by Courtney Davis. Background: a man by the name of Charles W. Hull first came up with the term 3D printing. A method called stereolithography was later named by him. Stereolithography is a method where he used thin layers of materials, printed layer by layer with UV light to form a 3D structure. Professor Adam Feinberg discovered free-form reversible embedding of suspended hydrogels. Fresh was used to print more complicated organs, such as heart and lungs, by printing soft biomaterials in a gelatin bag to overcome the constraints of printing with soft bioinks. This slide shows a diagram of the process that will be described in the next two slides. The process. The first step in the process is imaging. This is needed to have adequate outlines of the intricate designs of organs. X-rays, CT scans, and MRIs are the preferred ways of getting these images. The second step is choosing the design approach. Biomimicry, the creation of scaffolds that are made up of materials that work well in the body, and they are shaped as the organ. They are created to be the exact shape and size of the images from the patient. Autonomous self-assembly tissue, typically used for embryos, scaffold-free variant that goes through cellular replication. Mini tissues, uses a mixture of both biomimicry and autonomous self-assembly tissue, printing live tissues in smaller sizes to be connected together. Process continued. The third step is choosing the material to print with. Bioinks are the most common material used. Cell encapsulating hydrogels are used to print live materials. This allows for precise placement of the cells to form the tissue. The fourth step follows closely to the third. It is choosing the types of cells used for printing. This is dependent on the tissue they are trying to create. This is dependent on whether they need to be expandable tissue, lungs, or more sturdy tissue. The fifth step includes choosing the printer needed for the project. Inkjet. These printers can regulate the droplet size, and with the help of a controller, they drop bioinks into a gel-like substance in the precise shape needed. Extrusion. This printer produces a material that looks like what you would see in a normal plastic printing 3D printer. It extrudes a continuous material into the gel-like substance in layers. Laser-assisted printers. This printer involves printing a mold into the gel substance to be filled with the bioink. This is helpful by not chancing the compromise of the cells. Process continued. The sixth and final step is implantation. The 3D printing can be used for many different reasons, as seen in the diagram below. Pharmaceutical and high throughput screening. The use of 3D bioprinting technologies to build tissues and organs. Tissue engineering and regenerative medicine. Bioprinting and cancer research. Bioprinting for tissue transplantation. Pros and cons. Pros: no longer needing to wait for organ donation. Less animal testing. Able to customize to specific patient. Less organ rejection. In time, lower healthcare costs. Cons: limited amount of materials needed for printing. Low quality printers. Possibility of cell damage during printing. Conclusion: 3D bioprinting human organs will not only be a major part of how we handle organ replacement, but it will also help us further research medical questions that we do not have answers for. Being able to conduct tests will be more accessible, and they are being used for drug and cancer research. The technology is still evolving, and we will one day see 3D printed organs more in use than organ donors. Many patients die before they can get an organ transplant. A new organ generated from the patient's own cells would be a game changer. Dr. Creek.